Hi everybody. Okay, in this video we are going to talk about graphing tangent and cotangent. And just like the other four trig functions, these are considered periodic functions, so their graphs repeat. And the graph of the parent function comes straight from your unit circle. So just like we took our unit circle and we plotted the points for sine and cosine, we could do the same thing with tangent, okay? Now remember, tangent is y divided by x from your unit circle. So there are some angles where tangent is undefined, because anytime you would end up with 0 in the denominator, tangent is undefined. So if you think of your unit circle, that's going to happen at pi over 2 and 3 pi over 2. Okay, so if you look at this graph, this is our parent graph for tangent, you can see that we have vertical asymptotes in the graph at pi over 2 and 3 pi over 2, and then of course the same thing would occur at negative pi over 2 and negative 3 pi over 2. So if we then plotted additional points in between the vertical asymptotes from the unit circle, you would end up with a graph that looks like this. And the period for tangent, like the one period that we are going to deal with and transform when we're graphing these, is from negative pi over 2 to pi over 2. Okay, so this is one period of tangent, and then you can see that that one period is just repeated over and over. Okay, so let's run through the characteristics of the parent graph. And we're going to start with the vertical asymptotes. Since we have vertical asymptotes at pi over 2 and 3 pi over 2, and if we continued, it would be 5 pi over 2, 7 pi over 2. So we're going to say that our vertical asymptotes are x equals n pi over 2, where n is an odd integer. Okay. All right, now we're going to jump to the domain, because wherever we have a vertical asymptote or that break in the graph, those are angles or values of x where the tangent function is undefined. Okay, those are the angles where you're going to end up with 0 in the denominator. So we're going to say x cannot equal those values. Okay. Now, the range for tangent is actually all real numbers. So we're going to say negative infinity to infinity is the range. Okay, now the period for tangent is different than sine and cosine. One period goes from negative pi over 2 to positive pi over 2. Well, if you were to subtract those, pi over 2 minus negative pi over 2, you're going to end up with 1 pi. Okay, so the period for tangent is 1 pi. All right, now tangent does have a y-intercept. It does go through the origin, so the y-intercept is 0. And then the x-intercepts for tangent, again, they repeat, or they are infinite. So we look for that pattern. Your x-intercepts occur at 0, at pi, 2 pi, kept going, 3 pi, 4 pi, 5 pi. So we're going to say n pi, where n is an integer. Okay. All right, so this is your parent graph for tangent and its characteristics. You want to make sure you study this. But again, the part of the graph, or the period, that we're going to sketch when we transform these is between negative pi over 2 and pi over 2. Okay, so we're going to approach these a little bit differently than we did sine and cosine. It's all about the vertical asymptotes. Okay, as long as you can figure out where your vertical asymptotes end up after you apply your phase shift, which is going to be shifting the graph left or right, and you horizontally stretch or compress the graph, those are the transformations that are going to affect where your vertical asymptotes are, okay, or how you set up that x-axis. So we're going to start with the fact that our vertical asymptotes are at negative pi over 2 and pi over 2. Okay, so you want to remember this. And we're just going to call this our left VA and right VA. Okay, so remember for the parent function, the left VA is at negative pi over 2 and the right VA is at pi over 2. Okay, that's going to be important when we get to our example. Okay, so let's say we want to sketch this graph. Y equals 2 times tangent of 2x minus pi over 4. Okay, so if we were to label 2 as our A, the 2 inside the parentheses is B, pi over 4 is H, and then the K is 0 in this case. So because it's all about the vertical asymptotes, okay, or remember that for tangent of x, our parent function, the left VA is at negative pi over 2, and the right VA is at pi over 2. In order to set up our x-axis, all we're going to do is we're going to take what's inside the parentheses, the 2x minus pi over 4, and we're going to set this equal to negative pi over 2 and positive pi over 2. And we're going to solve those equations for x. And as we solve for x, we will be applying the phase shift and the horizontal stretch or compression, okay? So the solutions for x will represent the vertical asymptotes for our transformed graph. Okay, so let's go ahead and solve these equations. In the first one, I would start by adding pi over 4. Bring it down. Okay, now we're adding fractions, so we're going to need a common denominator. So I would convert that negative pi over 2 to negative 2 pi over 4 so that we have a common denominator. Then we'll add our numerators, so negative 2 pi plus 1 pi is negative 1 pi over 4. And then to solve for x, or to undo our multiplication, we're going to divide by 2 on both sides. But remember, that's the same as multiplying by 1/2. And that might be a little bit easier since we're dealing with fractions. Okay, multiply straight across, and we get negative pi over 8. Okay, so this is going to be our left VA. All right, let's solve the next equation. Again, we're going to start by adding pi over 4 to each side. We're going to need that common denominator, so we're going to convert pi over 2 to 2 pi over 4. We're going to add our numerators. 2 pi plus 1 pi is 3 pi over 4. That is equal to 2x, but then we're going to multiply by 1/2 on each side, and we're going to get 3 pi over 8. So that is going to be our right VA. Okay, so we're actually ready to sketch our graph. We're going to start with our x-axis. We're going to label the left VA and the right VA. Okay, you are going to need to find that middle point. So again, it's just like finding the midpoint. You're going to add your endpoints. Negative pi over 8 plus 3 pi over 8 is 2 pi over 8 divided by 2, which is the same as multiplying by 1/2. So we're going to get 2 pi over 16 or pi over 8. Okay. All right, so then let's go ahead and add our VAs. So remember, this is our left VA and this is our right VA. Now, we're going to sketch the graph of tangent. So, remember that this one period of tangent looks like this. This is the basic shape of the graph, okay? This is also where we need to think about A. A is a vertical stretch or compression. And if A is negative, it's going to reflect the graph over the x-axis, okay? So if A is greater than 1, that is a vertical stretch. So what that's going to do, if you kind of think of this like a rubber band, if you vertically stretch it, it's going to kind of straighten out the graph, okay? So basically, you're going to draw this graph a little straighter if it's a vertical stretch, okay? If it's a vertical compression, or if A is a fraction between 0 and 1, then imagine, walls closing in on the graph vertically. It's going to flatten it out a little bit, or you're going to make it more curved, like this, okay? And then if A is negative, you're just going to flip the graph over the x-axis, so instead of it being increasing, it'll be decreasing, all right? Okay, so let's go back to our example where our A is equal to 2. All right, since A is 2, that is a vertical stretch by 2. So when I draw my tangent graph, I'm just going to kind of try to straighten it out a little bit, okay, compared to the parent graph. And we have sketched one period of that function, okay? So with tangent, again, it's all about where the vertical asymptotes are. All right, let's look at cotangent. Now, the red graph here is the graph of cotangent. But again, if you think back to your unit circle, cotangent is equal to x over y. So cotangent is going to be undefined at 0 and pi. Okay, this is actually a VA. At 0 and pi, because for those angles, if you calculate x over y, y is going to be equal to 0. So you're going to end up with 0 in the denominator, and it's going to be undefined. Okay, then if we plotted some additional points, you would end up with the red graph for cotangent, okay? And again, the one period that we're going to focus on is this period right here from 0 to pi, okay? So just like tangent, the period for cotangent is 1 pi, okay? All right, so let's look at some of the other characteristics. Again, let's start with the vertical asymptotes. So here your vertical asymptotes occur at 0, 1 pi, 2 pi. If we kept going, 3 pi, 4 pi. Or we can describe it as x equals n pi, where n is an integer. And so that means our domain would be x cannot equal those values. Okay, and then the range is all real numbers, just like tangent. And the dashed blue graphs represent the graph of tangent, so you can kind of make a comparison between tangent and cotangent. All right, now, the y-intercept, cotangent does not have a y-intercept because we have a vertical asymptote at 0. But it does have x-intercepts, and so again, if we look for the pattern, your x-intercepts occur at pi over 2, 3 pi over 2, if we kept going, 5 pi over 2, 7 pi over 2, so on and so on. So we'll say n pi over 2, where n is an odd integer, okay? All right, so this is the graph of cotangent and its characteristics, and again, you want to be, familiar with these, make sure you study them. But the period that we're going to transform is the part that I highlighted in blue, which is from 0 to pi. Okay, so the key thing to remember with cotangent is that your left VA is at 0 and your right VA is at pi. Because we're going to use those to transform the graph. Okay, So let's look at an example. So we want to try to graph y equals 1/2 times cotangent of 2x minus pi over 2. Okay, so again, it's all about the VAs. We're going to take what's inside the parentheses, and we're going to set it equal to 0. This is going to help us find our left VA. And then we're going to take 2x minus pi over 2 and set it equal to pi. And this will help us find our right VA. 0 and pi are the VAs for our parent graph. So when we solve these equations for x, we're essentially applying that phase shift, and we will end up with our new VAs. Okay. All right, so let's go ahead and solve these. We're going to start by adding pi over 2 to each side. We're going to end up with 2x equals pi over 2. And then we're going to multiply by 1/2. And we're going to end up with pi over 4. Okay, we're going to add pi over 2 to each side, but this time we need a common denominator, so we'll convert pi to 2 pi over 2, and then we'll add our numerators. 2 pi plus 1 pi is 3 pi over 2, and then we'll multiply by 1/2, and we will get 3 pi over 4. Okay, we're ready to sketch our graph. We're going to set up our x-axis. So our left VA is at pi over 4. Our right VA is at 3 pi over 4. We're going to find that middle point. So we're going to add our endpoints. 1 pi plus 3 pi is 4 pi over 4, which is pi, divided by 2 is pi over 2. And then we're just going to sketch the graph for cotangent. Now, let's go back to our function. This is where we need to consider A. A is equal to 1/2. That is going to be a vertical compression by 1/2. So I just want to kind of flatten out my graph when I sketch it. And remember, cotangent is a decreasing graph. Okay, so maybe something like that. Okay, again, it's just a sketch. So, all right, so we will definitely practice this some more in class, just to make sure that you study those parent graphs and the characteristics, and that you know that for tangent, your VAs are at negative pi over 2 and pi over 2, and that for cotangent, your VAs are at 0 and pi. All right, thanks for watching. Have a good night.